So, you think Planet 9 exists with 99.8% probability?
Something like that. Yeah, maybe 99. I'll push it high. 99.9% probability.
It's just wishful thinking. It is. I mean, if you're that sure, find it.
In the farthest reaches of our solar system, way past Neptune and Pluto, a ninth planet may be lurking. It's predicted to have a mass 5 times that of Earth, and to orbit once every 10,000 years on a highly elliptical, inclined orbit. So why do some scientists suspect that such a strange object exists? That's what I've come to Caltech to find out. Where do you like to do your work?
You know, I usually do it wherever. Wherever I have a couple minutes of free time, I just do it. So this is where a lot of it gets done. My name is Konstantin Vatigan. I am a professor of planetary science at Caltech. And I do all kinds of astrophysics-y planetary studies, including stuff about Planet 9. These are variable transformations. I'll tell you where the Planet 9 boundary lies. It's like that. So everything to the left of that is all Planet 9.
So I'm here to find out about hidden planets and how to find hidden planets with math.
Okay.
So how do we do that? I mean, do you want to start at the beginning of this sort of endeavor, or do you want to jump into Planet 9? Where do you want to start?
Well, let's start at the beginning, because the beginning has a long and beautiful history to it. In its origins dates back to 1781, I believe, when Uranus was first discovered by Herschel. And when Herschel discovered Uranus, he immediately realized that the star that was slowly moving across the sky had actually been imaged many, many times before. And it was a matter of going back to old observations and kind of retracing the orbit that Uranus was following on the sky. And astronomers and mathematicians of the time immediately noticed that there was a problem with the orbit of this newly discovered planet. It was deviating from where it was supposed to be. But a French mathematician by the name of Urbain Le Verrier eventually did this beautiful and very complicated set of calculations that said, okay, if there is a planet there, right, in that part of the sky, then we can explain the anomalous motion of Uranus. And when once there was a mathematical prediction of where to look, astronomers were then able to discover Neptune with basically pinpoint accuracy.
How quickly did they find Neptune?
So this is a remarkable story. They found Neptune in one night because they knew exactly where to look.
There could be a ninth planet. There's a lot of space for a ninth planet in the outer solar system, but there's no good evidence for a ninth planet at the present time. And a particularly scary thing about the ninth planet is that a lot of people want to believe that there's a ninth planet. And we all know there's this huge psychological bias to the effect that if you want to believe something is true, you will find evidence, real or not, that it's true.
Everyone and their brother in the last 170 years have predicted planets beyond Neptune. But all of these theories have failed to date. I think that we, meaning myself and my collaborator / partner in crime, Mike Brown, are right. Our understanding of the solar system has evolved dramatically in the last 20 years. We've discovered that there exists this one additional belt of icy debris called the Kuiper Belt. These are kind of big icy asteroids that are maybe the size of LA, floating around beyond Neptune.
Who's responsible for finding the Kuiper Belt?
I found the Kuiper Belt with my student Jane Liu. You know that. We were looking for anything actually beyond the orbit of Saturn. So the puzzle in 1985, the puzzle was, why is it that the inner part of the solar system is full of asteroids and comets and all sorts kinds of things, planets, all this stuff, but then when you go beyond Saturn, there's Uranus, there's Neptune, and there's Pluto, and then that's it. Why would the outer solar system be so empty? So it's a very simple question of the kind that I can understand. And the answer was, well, let's have a look. You know, maybe it's not really empty. Maybe it is, in which case that would be interesting, but maybe it's not. So we started a survey to find stuff beyond Saturn. And we did the survey for a long time, 5 years or something, 6 years, and found actually nothing for that whole time, including nothing just beyond Saturn where we expected to find stuff, until finally in 1992 we got this thing way out, and we could tell immediately it's way out, 45 AU, 50 AU, from the slow motion across the sky. We found this thing out there, what we call now the first identified Kuiper Belt object. It's actually the second because Pluto was misidentified back in 1930 for all sorts of reasons connected with sociology and propaganda and things like that. People wanted to find a planet, and so no matter what, Pluto must be a planet. So that process has continued. We have more than 2,000 of these objects now. So in 25 years, 2,000 of these things have been found. We think the population is vast. There's 1 billion things bigger than a kilometer across, maybe more, maybe a couple billion. It's some of the more distant objects that appear to some people to show this orbital alignment. And they have, in particular, a very large perihelion distance, so they never come close to the Sun, they never come close to even Neptune.
And if you look at the most distant objects in this belt of debris called the Kuiper Belt, all of their orbits kind of point into the same direction.
Is it possible that there are some going in the other direction, we just haven't found them? They're there.
Yeah, of course, that's a great question. Generically, when you search for objects in the night sky, they're always what are called observational biases. You're always limited to finding objects only where you look. So this is a key question that you have to ask, right? Is it that we only found objects that are all pointing that way, right? Their orbits pointing that way because we only looked there. The answer is that there is a chance that this is all a false alarm, okay? And that chance is 1 in 500. There are bodies that occasionally will swing out into other directions. It's more that overall, if you look at it, there is an overall tendency. So here, what we see is a pretty typical kind of simulation of the type that we do. We start the solar system in an initially kind of totally random state where all the objects are pointing everywhere. For scale, these pink circles here are Uranus and Neptune, and this long ellipse, this long pink ellipse is Planet 9. These blue guys, these blue orbits, are long period Kuiper Belt objects, the ones that in the real solar system we see the clustering among, and these gold or greenish ellipses are the more short period, more proximate members of the Kuiper Belt, which are not clustered at all. So it takes a long time, but about 2 billion years into the evolution of the solar system, you begin to see the fact that objects that are collinear with Planet 9 have all been scattered away, removed from the solar system dynamically, and the only kind of remaining members of the distant solar system are the objects that point the opposite way. Again, it's a remarkable gravitational signature, gravitational one-way sign, if you will, that something is confining these orbits, keeping them clustered and pulling them all into the same plane.
You know, the experts, I think it was Scott Shepard and Chad Trujillo, who first noticed this alignment. They call it a 2.6 sigma result, which means that, you know, it doesn't really meet the threshold for acceptance. The scientific...
Would you be looking at 5 sigma? Is that...
I mean, the standard thing is 3 sigma, right? But half of all 3 sigma results are wrong, is what I always say as an observer. So the more significance, the better. But 2.6 is not enough.
So even though these clusters of asteroid orbits in the Kuiper Belt provide the best evidence for Planet 9, there's a chance that further Kuiper Belt observations will find different, unclustered orbits. But regardless, there are 2 other solar system mysteries that could be explained by the existence of Planet 9. These properties of Planet 9, they seem like kind of nuts. Like a period of 10,000 years, that's not like any of the planets that we have found. So why would we have such a strange planet hanging out there?
Yeah, great question. Indeed, none of this is reminiscent of anything solar system, right? If you, for a second, ignore the period, right, and ask yourself about, say, mass of 5 Earth masses. We don't have anything in the solar system that's 5 Earth masses. We go from 1 to 17 when we go from Earth to Neptune. Is it wild? Actually, turns out this is the most common type of planet in the galaxy that we have discovered around other stars. It may be reversed. The fact that the solar system doesn't host a object which is 5 Earth masses kind of closer to the sun is actually kind of weird. Indeed, 5 Earth masses, as it turns out, is kind of a standard outcome of planet formation. There are more wild things out there, okay? And this is really my favorite aspect of the Planet 9 hypothesis. It's the fact that Planet 9 actively flips orbits on their side. You should not expect to find objects in the solar system that are flipped on their side and are orbiting the sun perpendicular to the planets, and you should definitely not expect objects that are orbiting the solar system the wrong way, so to speak. Yet we find them, right? They exist in the Kuiper belt, right? And this has actually been a problem since before Planet 9 was even a thought. Planet 9 has this intriguing mode of dynamical evolution that it instills upon distant orbits, where it takes them and at the expense of kind of circularizing these distant objects, right, making their orbits less elliptical, flips them upside down and then makes them more elliptical again. It's a complicated dynamical evolution, and really at a detailed level you have to go to the computer simulations to understand how it works. But the key kind of product of the existence of Planet 9 is the expectation that such objects would exist, and we see them. And I really, there isn't another kind of natural mechanism to generate these highly inclined bodies.
You know, you have the plane of most of the bodies, and then some of the bodies out there apparently have their orbits almost tilted up to 90 degrees. Mm-hmm. Is that just weird, or is that stronger evidence for...
That's one of the things that they claim to explain with the Planet 9 hypothesis, and that's a good thing, in favor of the hypothesis. But again, you know, you need to find the planet to be sure of what's going on. In the region that we have not yet been able to probe, because we can't see faint enough, we don't know. Yeah, we don't know.
So when do you think we're going to find Planet 9?
That's a great question. So observing the sky has proven to be an extreme challenge. The search for Planet 9 is extremely difficult. It's just kind of dim enough at the outer parts of its orbit where it can be discovered with current telescopes, but everything has to go right. And by everything it has to go right, I mean no moon, the atmosphere has to be calm so that the light is not messed up by turbulence. Such nights do come around every year, but they don't come around very often. So since 2017, we've had exactly 2 successful runs, right? Successful observational runs where we had sort of a string of nights where we could take pictures of the same part of the sky over and over again. So we're about 20%, maybe a little bit more now, 25% done with the survey that we are carrying out to search for Planet 9. If things go at this rate, it might take about a decade. I think the commencement of the LSST telescope, which is coming online 2022-23, that's going to help a lot, because that's going to, first of all, discover many more of these objects, and we'll be able to refine the theoretical model better. And also, just by direct observation, it'll rule out, or it'll either find Planet 9 or rule out a big chunk of its orbit, so we could kind of zero in that way a lot more. So it's an iterative process. I would guesstimate decade or less.
So volumetrically, we've discovered most of the solar system in the last 25 years, something like that.
What do you mean volumetrically?
I mean that the volume of the region occupied by the planets is very small. It's 10,000 cubic astronomical units. But as you go further out, you know, the volume of that sphere that encapsulates all the objects that we've been able to observe is just going up dramatically. So if you go 10 times further out, which we are now just about able to do, you increase the volume that you're looking at by a factor of 1,000. There's a whole bunch of stuff going on. You know, solar system is, to me, an unknown place. You know, we fool ourselves to thinking that we know everything about it just because we've only been looking close and we have a lot of data from spacecraft and so on. But the further away you go, the less known it is and the more mysterious it is. And this ninth planet thing is part of that, because essentially when you go far enough away from the sun, there's enough room to hide almost anything you want. It will be so faint you can put almost anything. Big planets, small planets, whatever you want. We would not have seen it yet.
If and when you do find it, who gets to name it?
Oh, that's something we don't think about and don't talk about.
You don't have a name in the back of your head?
Only David Bowie. Yeah, there's an online petition on change.org to name Planet 9 David Bowie, and I thought it was kind of silly initially, but then there's this whole David Bowie like mythology that you could create. If it has moons, you could have Ziggy Stardust and Starman and all of these things. So kind of like, I'm not saying that seriously, but also it would be kind of remarkable if we had Jupiter, Saturn, Uranus, Neptune, and David Bowie.